have a few minutes to go.
Hello.
Around.
Hello.
Yeah. We'll start in 3 minutes. Hello. Yeah, 2 minutes warning we are given. We'll start in 2 minutes. Good afternoon. Welcome everyone here. This is the session on what is emerging workloads and how to exploit abstractions and operators. I am Prakash Ramchandran from Dell, and here is my colleague Digambar Patil from CalSoft. We had participation from Sujata, Intel Santa Clara, Madhuri Intel from Bangalore, and then we have Professor J. Gokhale from BITS Mumbai for Goa and Pilani. So this work relates to what is emerging workload, and you can see at the top there is a logo which is indicating brain, that is Medhavi. Medhavi in Sanskrit means intelligent. So we are talking of intelligence, and on the right side you see OTF, that is Open Technology Foundation. So the work is being done in Mumbai under Open Technology Foundation to start with, which we want to incubate into open infrastructure. So with that, let me start the first, what is workload? So workload are of different types. At least you can see 3 of them. One is the network function, which is there from 2013, 2012, around the time when the HC put out the specification for NFV. So network function can be virtual, can be physical. Now, network function as a service is what most of the telco want, because they have network functions which they want to deploy in a volume to be able to support consumers as well as enterprises at a large scale, whether they are a tier 1 provider like AT&T or China Mobile, or tier 2 providers which could be with a lesser amount of volume with respect to tier 1. Like example, if I take China Mobile, they would have somewhere around 1.5 billion customers and 900 active SIM users. So you can see the volume. And same way if I take AT&T, it will be around 100 millions. So we are talking of 100 millions to billions and billions. Those kinds of volumes to manage for a network function is the hard task. So workload is distributed as well as it needs to be balanced, load balanced, and that's the way. So software load balancer, firewall, service chaining, these are some of the use cases which define the enough network function workloads, virtual or physical. Then I go to AI and ML. AI and ML is artificial intelligence and machine learning. The machine learning as a service is what they require. Their workload again characterizes. Example, you saw in the Intel boot here, they had a EV, electronic, that is EV charger. A car is entering and it has got a nameplate, and that nameplate has a character and an image. So the image recognition recognizes, and the Starlink X inside kicks up and tries to do the banking, connects with the banking gateway to the charger. The guy fills the electric vehicle, he charges and he pays for it automatically. And plus this can be used for other services. So that kind of a machine learning as a service is the workload we are looking at. And it can include character recognition, it can include speech, vision, whatever. So all the human faculties, including robotics, etc., whatever we can recreate. Then the third workload type is big data, which is defining the data analytics which you can use for generating how healthcare, multiple verticals. I take healthcare because that is a key, because healthcare vertical produces the lot of data about lot of people, and you have to ensure that you have a data protection as well as you are able to take the data and generate the analysis to improve the outcomes. So the next one we are taking up is what is declarative, what is imperative. So programming model is essential for automation. And the model, what you do depends on how you do, or what is it and how it is. So what is it part of is declarative. If you can declare the entire hardware, the software, the firmware, the middleware, any other ware you want. And if that is the YAML descriptor, that gives you what is the schema. Example, you do in Kubernetes K8s with the kind schema. So you can describe the components of the hardware, the software, example, the bare metal, the pod, the VM, the stack, etc., etc. You can compose, and then that is what is the declarative specification. Now, imperative programming model, how do I do it? Day one, do I install it? Do I boot it? Do I, after booting, do I upgrade it? Do I maintain the life cycle of the hardware, the software, the firmware, VM, all that? So the whole 9 yard which follows, that's used with imperative programming model. So the problem we have right now is, yes, what we do is declarative is what we are focused on, and the conclusion is we start with declarative. So Medhavi is the one which is a new project we are proposing. We have the POC working on, and that generally takes the infrastructure components like bare metal, container, VM, and then it composes out of these compute storage and network resources, the combinations, the type of devices you use, GPU, CPU, FPGA, SmartNIC, whatever you have, and that is the basis for it. Once you have that basis, then you go, you map the workload, take the workload type, as I described the workload type, AI, ML, NFV, or it is bare metal, or a database as a service, or whatever, big data as a service. You model that, and then you have components, bunch of inventory for whatever you want, pools, node pools, the various elements which are associated with them, the images. So basically, you have all the pools of devices, all the pools of nodes, and the associated trades. OpenStack in the early days has been evolving for at least 6 or 7 versions of trades have come. traits are the hints, are the traits describe the characteristics at the device level, which are then used from the workload at the top. And the workload, like example, you have Ionic, you have got Cyborg, they have got the ability to work at the device level. On top of it, they provide the hint which are being used by the workload. And workload abstraction, here is the node pool, the intensity, whether it's a storage intensive, compute intensive, network intensive, Nova does not fit this. So we don't want, in this Nova, we want to have a new workload manager which will be able to develop based on, Nova is based on NASA, and we are looking at Lawrence Livermore Laboratory for a newer HPC type of implementation. And here is the various architectural level framework. At this time, I think I should bring in Digambar. So the only thing I'll say is this is nothing very much like Kubernetes controller, but at the same time, not so like Kubernetes controller in the sense that it is not going to use anything with Nova, but we will have a new workload manager.
Correct. So currently, we are giving a JSON-based template, and that template will pass into API manager, and API manager is kind of distributed in different pods, and that different pods are talking to different DB pods, and each and every node agent means actually our node resource and device agents sitting on different infrastructures, and those node agents are pulling data from there. Okay, so this is our as part of Medhavi. So Medhavi we split in the five pillars. These are the 4 pillars of open infra, and we are fitting Medhavi as a 5th pillar in this open infra stage. So I'll go directly into service architecture of Medhavi. Medhavi is a completely workload optimization tool, like Prakash explained. So we have a CLI dashboard. We have a API controller, which is all this architecture sitting on based out of Kubernetes. So we have a device engine which is actually pulling all the information about the devices and all type of network functions, virtual functions, physical functions, and pull it. And in the recommendation engine is based out of what kind of workloads you are passing to the API, and what kind of devices, what kind of capabilities you have. Based on that, we are making recommendation out of by configuring different algorithms in machine learning. So ML engine is actually processing and processing data, processing ML jobs in distributed environments with the help of TensorFlow. And the ML cluster is actually creating a cluster of TensorFlow, PyTorch, and everything. So this is ML cluster, is ML engine, and ML cluster is specifically designed for clustering and distributing workloads and training them. Actually, the model will be processed in distributed environments and processed in parallel. So this is the architecture of Medhavi, and so these are one of the repositories we are developing from our side. So you can join them. This is an open source project we are incubating, and we already have done some POCs around it. So you can go through these repos. So going ahead, Prakash.
At this time, I will say that one thread is workload testing. So like Netflix has done A/B testing, you have a workload, you run a video workload. Then you have a A/B testing path, which is 80% goes here, 20% goes to the A/B path, the B path. And that B path, you do experiment. So this can be a live experimentation to make it dynamically more optimized. And our goal in Medhavi will be to whatever the intelligence you feed, how can we optimize live, like OpenFlow does for the networking, we will have this for the compute workload. So that we are, even though it may be distributed, so we are looking at open API from Intel, open API from Intel and oneness, or one API from Intel and openness from Intel. Those are the two. We have one look at the Lawrence Livermore's HPC implementation, and then we are also looking at Airship as the base. So we don't want any connection with legacy. OpenStack legacy, last 20 versions, fine, that's good for current players. For the future players, it will be the open infrastructure, and in that direction we are moving. The part of intelligence which I mentioned earlier, which was there, So the fifth pillar is what we want to ensure that takes as one of the key pieces of this. So the takeaway is that you have under cloud deployment using Airship. Airship is moving to 2.0. That will be the base for this. And then after that, for distribution, we do have Starlink as another combination. And the third, of course, Zool is for the continuous integration, and Kata is for the container security. So these four being there is one push for intelligence as a service, and which is what we want to introduce. Coming once we have the PTG, we will have the specification and all. Right now we have gone through the POC and we have realized what the issues are and how to overcome them. So we are working with the dependency projects like Cyborg, Ionic, Airship. These are the dependencies we have defined. We have not defined yet whether we should depend on Neutron or not. We have not defined some of the Keystone is one possible candidate. So we are looking at what can be done with the microservices that exist and what are that we do not want, because that comes in a way of the optimization, because we need to write a new scheduler or at least borrow a new scheduler, and which we want to be based on the HPC, high performance computing. So this is an ongoing effort. This has taken 6 months approximately. You will see that maybe Vancouver, after the Vancouver, whatever comes next, that's the place probably we'll be able to mature and project it as a full piece. We are looking at the telcos, and some of the Indian telcos are ready to support us, so we have a very good chance of success, because at the end of the day, if there is no user, there is no use of this. So we are identifying the users. We are looking at one of the primary telcos in India to be the use case. So you look forward to these as a great opportunity to jump on. So we are looking for people who can contribute and who want to support. And therefore, I will just, before closing, I'll just put this. This is the GitHub where we have the code, POC code. We are having a Medhavi meeting tomorrow. So those who want to join can join us. We'll obviously do it here only. We are in open. We don't have any not here exactly, but at the PTG location, in one of the tables we'll be doing. Any questions, please ask. We are willing to answer anything, whatever you need. Any questions? Try it out. Try us out. Sure.
So you spoke of FPGA, GPU. So have you done some concrete things with FPGAs? Concrete use cases with FPGAs?
FPGA is actually capable of handling, for machine learning, is capable of handling compute and memory intensive workloads. So currently we are in, because Madhavi from Intel and Sujata, they are looking after that. So maybe I think Prakash can more.
So offloading is one of the key usage for FPGA, and what we look at is the model being burned into the FPGA is one aspect of it. The other aspect of it, what I have seen is we want to be able to use the FPGA to switch between the CPU and the GPU, so that has already been, POC has been presented in other conferences. We are talking to them to see that how we can leverage, because heterogeneous computing is the next in. You are going to have heterogeneous elements for compute itself, CPU, GPU, as well as you are going to have models based on FPGA. And then, so those are the aspects we are reviewing. We have not made any conclusive decisions. If you have any idea, we would like to take from you.
Not just saying that there is no standard, because if you take Intel FPGA or Xilinx, it's completely different way of programming, different types of bit stream. So there is no standard for FPGA.
Agreed. There are no standards for things, but this is where OpenStack comes into it, and we believe that we will be able to work out those details with the ecosystem we have. And it is not just necessarily OpenStack. We are also talking to CNCF. We are also talking to Linux Foundation. We are finding out what are the best way. And plus, there are standard industry bodies which deal with FPGAs and all the elements associated with that as to how to do the offloads. And Cyborg has already implemented one of it. And we are definitely talking to them And certainly we will consider any new inputs from standardization aspects or from use cases aspects that emerge besides what we have documented. Thank you. That was a great question. Anyone else? Come on. Get up. Where are Chinese folks, man? You are the ML experts. Come on. Get up. Talk something. Ask something. No? Okay. Thank you very much, and we appreciate all your support. And we look forward to come again and give you a better view of what we have done next time. Thank you.